Yes, so I'm showing a family of Poncelet triangles, blue ones, interscribed between an outer ellipse, some aspect ratio, and an inner caustic. And I'm going to make sure that this caustic is a circle, okay? Now I'm interested in varying the center of the circle and obtaining a new radius such that I continue to close Poncelet n equals 3. So this app allows me to actually drag the center, and I'm behind the doors doing a computation, a numerical computation, to find what that radius is, okay? And wherever I place this, the center of the circle, I get the right radius, and I get a new family of Poncelet triangles, okay, wherever I place C. Now, what I'm also showing here are level curves of R, of the radius of this brown caustic, okay, such that I continue to close Poncelet. So for example, if I grab onto this 0.3 level curve and I drag C, and here I'm doing this manually, across that level curve, the radius of the caustic is not changing, and I continue to close Poncelet. And I wanted to know what the shape of these level curves was. So for example, if I'm here at the 0.15 range, the circle must be much smaller for Poncelet to close. And I wanted to know what the shape of these level curves of the radius of R, little r, were, so that Poncelet remained closed. And it looks like it's a family of ellipses. Now proof is still outstanding. It's a family of ellipses. So here's the 0.55 ellipse. Okay, radius equals 0.55. And by the way, the aspect ratio of this particular outer ellipse here is 3/2. Okay, so I have 1.5 on A and 1 on B. So you can see here that at 0.55 I get this level curve for C, and I continue to close my family. The radius is shown up here. I'm doing this manually, so it's not exactly 0.55, but you can see here that if I do this, if I stay on this curve, that required radius remains constant at around 0.55, and I continue to close my Poncelet. Okay, now what remains to be proved is whether these curves are indeed perfect ellipses. They seem they are. I've done some preliminary testing with them. And what is exactly determines their progression from the aspect ratio of the outer ellipse to what tends to become just a point here on the center, right? So the innermost level curve is that point, okay, and that's the highest. It's basically the maximum of this family of level curves, right? So if I go out here, I get these really tiny circles. For example, here, I get this circle and I get that, right? So I can now move across that level curve and preserve the Cayley n equals 3 condition. Okay, all right, so that's all I have for now.